The conference room in the Navy Ministry building smelled of cigarette smoke and confidence. It was April of 1941, and Commander Minoru Genda sat among 24 of Japan's finest naval aviation planners, reviewing charts that showed American aircraft production capacity. The numbers seemed manageable. America produced roughly 6,000 military aircraft in 1940. Germany had built over 10,000. Japan itself had manufactured nearly 5,000. The arithmetic suggested parity, perhaps even advantage when combined with superior training and the element of surprise. What none of the men in that room understood, what they couldn't possibly have understood, was that they were reading the closing chapter of an old story, while America was already writing an entirely different book. Genda had every reason for confidence. He'd studied at the Naval Staff College, analyzed carrier doctrine, and helped plan the strike that would soon bring America into the war. The calculations were straightforward. Japan's war plan assumed a limited conflict. Strike hard, seize the resource-rich territories of Southeast Asia, establish a defensive perimeter, and force the Americans to accept a negotiated peace. The United States, they believed, lacked the will for a prolonged Pacific War. Democracy made nations soft. Their society was divided, materialistic, individualistic. Americans would choose prosperity over sacrifice. Japan had spiritual strength, tactical excellence, and warriors willing to die for the emperor. These advantages would overcome any material disparities. The intelligence estimates supported this worldview. American society seemed fragmented by labor strikes, racial tensions, and isolationist politics. Their military remained small, less than 200,000 men under arms in 1940. Their navy, while substantial, was split between two oceans. Their aircraft industry, the reports suggested, was oriented towards civilian production and would take years to fully convert to military manufacturing. Japan would have 18 months, perhaps 2 years, to establish facts on the ground that no American president could reverse without political suicide. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Genda and his colleagues didn't know, what they had no framework to imagine, was that American industrial capacity wasn't just larger than Japan's. It was larger in ways that defied the arithmetic of conventional warfare. In 1941, Japan's entire economy produced approximately $5 billion in manufactured goods annually. The United States produced nearly $90 billion. But these were abstractions, numbers on paper that didn't translate into tactical reality for men planning carrier strikes and amphibious assaults. They understood production in terms they'd seen, factories they'd visited, assembly lines they'd observed, industrial processes that fit within their experience. They couldn't envision what they'd never witnessed. The Japanese aircraft industry in 1941 represented the pinnacle of their manufacturing capability. Mitsubishi, Nakajima, Kawasaki, and Aichi employed the nation's finest engineers and most skilled workers. The Zero fighter, officially the Type 0 carrier fighter, or A6M, embodied this excellence. It could outmaneuver any carrier fighter in the world. It had a range of nearly 2,000 miles. In the hands of Japan's superbly trained pilots, men who'd spent years in combat over China, it seemed invincible. Production reached 25 aircraft per month in early 1941. This seemed adequate. Japan's entire carrier force numbered fewer than 500 aircraft. Replacement needs appeared modest. The training system reinforced this confidence. Japanese naval aviators underwent years of preparation. Primary flight training lasted a year. Advanced training added another year of gunnery, navigation, and carrier operations. Only the best survived this winnowing process. By 1941, Japan possessed approximately 3,000 fully trained naval aviators, and perhaps 1,500 were elite veterans with combat experience. These men weren't just pilots. They were a warrior caste, sons of samurai tradition, educated in the Bushido code that made death preferable to surrender or failure. American pilots, intelligence suggested, received 6 months of training and came from soft civilian backgrounds. They flew for pay, not honor. The qualitative advantage seemed overwhelming. American aircraft observed in the Philippines and at Pearl Harbor reinforced Japanese assumptions. The P-40 Warhawk was inferior to the Zero in almost every performance category. The Brewster Buffalo, deployed by the Marines, was worse overweight, underpowered, and sluggish. American torpedo bombers were slow and vulnerable. Their dive bombers lacked range. The B-17 Flying Fortress bomber impressed Japanese observers with its defensive armament, but it couldn't sink ships and appeared unsuitable for Pacific operations. The gap between Japanese and American aviation seemed not just tactical but philosophical. Japan built aircraft for warriors. America built aircraft for technicians. This worldview shaped every calculation. When planning the Pearl Harbor strike, Genda and his superior, Admiral Isoroku Yamamoto, assumed they needed to cripple the American Pacific Fleet for 6 months to a year. This would provide the window Japan needed to secure the oil fields of the Dutch East Indies, the rubber plantations of Malaya, and the rice paddies of Burma. American industry would need time to recover, time to build, time to transport forces across 6,000 miles of ocean. By then, Japan would control an empire so vast, so economically self-sufficient, that America would have no choice but to accept the new reality. The mathematics of logistics, distance, transport capacity, fuel consumption, repair facilities, all favored the defender in the Pacific. Japan would be the defender. The first 6 months seemed to validate every assumption. Pearl Harbor removed American battleship power from the Pacific. The Philippines fell, Wake Island fell, Guam fell. Hong Kong, Malaya, Singapore, Burma, the Dutch East Indies, the Greater East Asia co-prosperity sphere became reality at a speed that exceeded even optimistic Japanese projections. By May of 1942, Japan controlled territory stretching from the Indian Ocean to the Central Pacific, from the Aleutians to the edge of Australia. American aircraft losses in these campaigns exceeded 1,000 planes. Pilot casualties were severe. The remnants of American air power in the Pacific appeared scattered, demoralized, and technologically outmatched. Even Midway, the first significant setback, didn't fundamentally challenge the core assumptions. Yes, Japan lost 4 fleet carriers in a single day in June of 1942. Yes, this represented a blow to offensive capability, but the losses seemed replaceable. Japan still possessed 8 fleet carriers and several light carriers. The pilot casualties, while severe, represented perhaps 150 men from a force of thousands. American production advantages would take time to manifest. The war remained winnable if Japan maintained its defensive perimeter and bled American forces in a war of attrition. The mathematics still made sense. Or so it seemed. The first hints of a different arithmetic appeared in the casualty reports from Guadalcanal. The Americans landed on the island in August of 1942, and Japanese naval aviation threw itself into the battle to dislodge them. The losses mounted with disturbing speed. The First Air Fleet, rebuilt after Midway, sent wave after wave of bombers and fighters against American positions. The Americans kept shooting them down, not occasionally, not in acceptable numbers, consistently, devastatingly. Japanese squadrons that sortied with 18 aircraft returned with 9, then 6, then 3. The Americans replaced their losses. Japan couldn't match the pace. By November of 1942, just 5 months into the Guadalcanal campaign, Japan had lost more than 800 aircraft and nearly 1,500 aircrew in the Solomon Islands theatre alone. This represented more planes than the entire first-line strength of the Pearl Harbor strike force. More troubling than the numbers was the nature of the replacement aircraft arriving from Japan. They weren't better than the Zeros and Bettys they replaced. They were identical. American aircraft, by contrast, were changing. The F-4F Wildcat, which had been roughly equal to the 0 in combat, was being supplemented by something new, the F-6F Hellcat. Pilots returning from encounters with this aircraft reported it was faster, more heavily armed, and far more rugged than anything they'd faced before. It could dive away from a 0. It could take punishment that would destroy a Japanese fighter, and there seemed to be more of them arriving every month. The intelligence reports from late 1942 began including numbers that seemed impossible. American aircraft production for the year was estimated at 48,000 military aircraft. Japan had produced approximately 8,600. The disparity was so extreme that staff officers questioned the reliability of the intelligence. Perhaps the numbers included trainers and civilian aircraft. Perhaps they reflected authorized production rather than actual delivery. Perhaps American security was feeding false numbers to intimidate Japan. The alternative, that America had genuinely produced 5 times as many military aircraft in a single year, was too devastating to accept. It meant the entire war plan was built on arithmetic that no longer applied. But the evidence kept accumulating. In the fighting around New Guinea and the Solomons throughout 1943, Japanese pilots encountered American aircraft in formations that seemed to violate basic logistics. Where were they all coming from? How were they being maintained? Who was flying them? A single American carrier, pilots reported, could launch more fighters in one wave than Japan could assemble for an entire operation. American land-based bombers appeared in numbers that made interception suicidal. The B-24 Liberator, a 4-engine heavy bomber, flew from bases that should have been beyond its range. When Japanese forces overran those bases, they found stockpiles of fuel, ammunition, spare parts, and aircraft components that suggested American logistics operated on a scale Japan couldn't match. The training reports were perhaps more disturbing than the production numbers. Captured American pilots, when interrogated, revealed they'd received between 9 months and a year of flight training. This was less than Japanese standards, but far more than intelligence had suggested. More troubling, these pilots described a training pipeline that graduated thousands of new aviators every month. Every month. Japan's entire training system produced perhaps 200 fully qualified naval aviators monthly, and this was straining instructional capacity to the breaking point. If the American numbers were accurate, and the evidence suggested they were, then the United States was training more pilots in a month than Japan could train in 6 months. The arithmetic was becoming inescapable. By mid-1943, the nature of air combat in the Pacific had fundamentally changed. Japanese formations no longer operated with the confidence of 1941. Every mission was now flown with the knowledge that American fighters would outnumber them, that American anti-aircraft fire would be intense and accurate, that losses would be heavy, and replacement pilots would be inadequately trained. The veteran pilots who'd struck Pearl Harbor and ranged across the Pacific in the war's first year were dying faster than they could be replaced. Their replacements had months of training where the veterans had years. The Americans seemed to have an inexhaustible supply of both aircraft and adequately trained pilots. The November 1943 strike against the American carrier fleet near the Gilbert Islands illustrated the new reality with brutal clarity. Vice Admiral Takeo Kurita led Japan's carrier-based air power, approximately 160 aircraft, in a desperate attempt to stop the American advance across the Central Pacific. The strike force launched and encountered an American combat air patrol of more than 40 Hellcat fighters. The ensuing battle destroyed more than 50 Japanese aircraft in exchange for fewer than a dozen American planes. But what shocked survivors wasn't just the loss ratio. It was the revelation that the American carriers, which intelligence had estimated would have perhaps 60 fighters total, seemed to have endless reserves. Wave after wave of Hellcats engaged Japanese formations. Where were they all coming from? The answer, though Japanese intelligence didn't fully comprehend it yet, lay in the Essex-class fleet carrier program. The United States launched its first Essex in December of 1942. By the end of 1943, 9 more were in commission or completing trials. Each carried approximately 90 aircraft. Japan, which began the war with 10 fleet carriers, now had 5 operational and no new construction scheduled for completion before late 1944. The arithmetic of carrier aviation, the calculus that shaped Pacific naval warfare, had tilted so far toward America that strategic planning became an exercise in damage control rather than victory planning. Commander Genda, now serving on Admiral Ozawa's staff, reviewed these numbers in early 1944 and confronted an intellectual crisis. Every assumption that had shaped pre-war planning was proving false. America wasn't negotiating. American democracy hadn't produced weakness, but rather extraordinary mobilization. American industry wasn't converting slowly, but had achieved production volumes that dwarfed Japan's entire economy. The limited war Japan had planned was becoming a war of annihilation, not because American strategy demanded it, but because American production capacity made any other outcome impossible. Japan was fighting arithmetic, and arithmetic was winning. The Marianas Campaign in June of 1944 removed any remaining illusions. The Japanese Navy assembled its remaining carrier-strength 9 carriers with approximately 430 aircraft for a decisive battle to stop the American advance. The operation was called AGO, and it represented Japan's last opportunity to achieve strategic equilibrium through tactical excellence. The pilots were less experienced than those of 1941, but they were still dedicated warriors. The aircraft were still Zeros and Judys and Jills, tried and proven designs. The plan was sound. If Japan could destroy several American carriers, it might force a negotiated settlement. The mathematics of replacement suggested America couldn't sustain heavy carrier losses without a significant operational pause. The Battle of the Philippine Sea destroyed these calculations in a single day. American carriers, 15 fleet carriers, and numerous light carriers launched approximately 450 fighters against the Japanese strike forces. The result wasn't a battle, it was slaughter. American pilots, flying aircraft that were faster, tougher, and more heavily armed than their Japanese counterparts, destroyed more than 300 Japanese aircraft in exchange for fewer than 30 American planes. Japanese pilots called it the turkey shoot, though this name came from American sources. Japanese survivors had no name for what they'd experienced. It was beyond nomenclature. It was the arithmetic made visible. But numbers alone don't capture what had happened. The Battle of the Philippine Sea revealed that America had achieved something Japan couldn't match: the ability to learn, adapt, and improve at industrial scale. The Hellcat wasn't just a good fighter. It was a fighter designed specifically to counter the Zero, built in quantities that made it ubiquitous, flown by pilots, trained in tactics, developed through scientific analysis of combat data, and supported by logistics that ensured every carrier had spare aircraft, replacement pilots, ammunition, fuel, and repair capacity. This wasn't just superior production. It was a system, a way of making war that integrated industry, training, doctrine, and logistics into a mechanism that improved continuously while growing constantly. The reconnaissance photographs told a story that Japan's military leadership struggled to comprehend. In September of 1944, intelligence officers spread aerial images across a conference table in Tokyo. The photographs showed American naval anchorages at Ulithi Atoll in the Caroline Islands. Officers counted the ships visible in the images: more than 60 carriers, dozens of battleships, hundreds of cruisers, destroyers, and support vessels. This represented more combat tonnage than Japan had possessed at the war's beginning, and it was just one anchorage. Similar concentrations existed at Eniwetok, at Manus, at dozens of forward bases that hadn't existed a year earlier. Commander Genda studied these photographs with the trained eye of a man who'd spent his career analyzing naval power. What disturbed him wasn't just the quantity of ships, it was the timeline. Many of these vessels, the Essex-class carriers, the Cleveland-class cruisers, the Fletcher-class destroyers, hadn't existed when the war began. America had designed them, built them, trained crews for them, and deployed them across 6,000 miles of ocean in less than 3 years. Japan couldn't match this pace. Japan couldn't even comprehend the industrial processes that made it possible. These weren't just ships. They were evidence of an economic capacity so vast it redefined what warfare meant. The aircraft production numbers, when they finally arrived through intelligence channels, seemed like errors. American aircraft production for 1943, approximately 86,000 military aircraft. For 1944, the estimate exceeded 96,000. Japan's production for 1944 was projected at 28,000 aircraft, and this represented maximum industrial mobilization, stripping resources from civilian economy, implementing 24-hour factory operations, and conscripting women and older men into manufacturing work. America was producing aircraft at 3-to-1 ratio while simultaneously building the largest navy in human history, supplying Britain and the Soviet Union with thousands of aircraft and vehicles, and maintaining civilian living standards that Japanese intelligence reports described as almost incomprehensible in their abundance. The specific numbers revealed the depth of disparity. In 1944, American factories produced approximately 18,000 fighters. Japan produced approximately 13,000. But Japanese fighter production included training aircraft, obsolete models kept in production because tooling couldn't be converted, and aircraft built to replace attrition rather than expand combat strength. American fighter production was almost entirely frontline types: P-51 Mustangs, P-47 Thunderbolts, F-6F Hellcats, 4U Corsairs. Each aircraft was more capable than its predecessor. Each was produced in quantities that made tactical losses operationally irrelevant. The bomber disparity was worse. America produced approximately 16,000 bombers in 1944, many of them 4-engine heavy bombers, B-17 Flying Fortresses, B-24 Liberators, and increasingly the B-29 Superfortress. Japan produced approximately 5,000 bombers, mostly twin-engine medium bombers, with ranges and payloads that couldn't match American types. The B-29 particularly represented a capability Japan couldn't counter. It could fly at 30,000 feet beyond the effective ceiling of most Japanese fighters. It carried a bomb load of 20,000 pounds across a combat radius of more than 1,500 miles, and American factories were building them at a rate of over 300 per month by late 1944. Lieutenant Commander Saburo Sakai, one of Japan's most successful fighter pilots, with more than 60 confirmed victories, encountered the new arithmetic personally in October of 1944. His squadron, defending the Philippines against the American invasion, launched 18 Zeros to intercept an American carrier strike. They were outnumbered 3-to-1 by Hellcats. The battle lasted less than 20 minutes. Sakai's squadron lost 12 aircraft. They claimed 4 American fighters destroyed. Even if this claim was accurate and combat claims were notoriously optimistic, the exchange ratio was devastating. At 3-to-1 losses, Japan's remaining pilot strength would be exhausted in months, and the Americans kept coming. After the battle, Sakai watched American carriers launch replacement fighters to cover their fleet. The sky seemed full of them, as if America had discovered how to manufacture aircraft faster than Japan could shoot them down. The pilot training disparity had become critical. By late 1944, Japanese naval aviation was accepting pilots with as little as 3 months of flight training. These men could barely fly their aircraft, let alone engage in combat maneuvering against experienced American pilots flying superior planes. The veteran pilots like Sakai tried to protect the novices, but this was increasingly impossible. American fighters hunted in coordinated teams, using radio communication and tactical discipline that Japanese formations couldn't match. A novice Japanese pilot encountering 4 Hellcats operating as a coordinated unit had no chance. The veteran pilots died trying to cover them, and the novices died anyway. The mathematics of attrition had become inexorable. The American training pipeline, captured documents revealed, was producing approximately 4,000 qualified pilots per month by mid-1944. This included training for fighters, bombers, transports, and reconnaissance aircraft. Japan's entire pilot training system, running at maximum capacity, produced perhaps 800 pilots monthly across all specialties. But the disparity was more than numbers. American pilots arrived at operational squadrons with between 250 and 300 flight hours. Japanese pilots were arriving with as few as 100 hours. In air combat, this differential meant life or death. Experience couldn't be manufactured quickly, and Japan was running out of experienced pilots faster than it could train replacements. The logistics supporting American air operations revealed another dimension of disparity. When Japanese forces examined captured American air bases in the Philippines and later on Okinawa, they found supply dumps that contained more aviation gasoline than Japan's entire monthly production. Spare parts existed in such quantities that American squadrons could cannibalize damaged aircraft without impacting operations. Ammunition stocks were measured in millions of rounds. The Americans discarded equipment that Japanese forces would have considered treasures: tires, tools, generators, radio equipment, even aircraft with repairable damage, all left behind because American logistics made replacement easier than repair. A specific incident illustrated this abundance with almost cruel clarity. In November of 1944, American forces advancing through the Philippines overran a Japanese airfield at Ormoc. They found the Japanese had been cannibalizing 5 damaged Zeros to keep 2 aircraft operational. Fuel was so scarce that pilots were conducting training flights lasting less than 30 minutes. Ammunition was rationed to the extent that gunnery practice had been suspended. At the same airfield, abandoned after American forces captured it, American engineers arrived within 48 hours and began constructing facilities for an entire fighter group. Within a week, they'd laid steel matting for runways, erected fuel storage facilities holding hundreds of thousands of gallons of aviation gasoline, and stockpiled ammunition measured in tons. The Japanese defenders, watching from jungle positions, saw in microcosm what they were fighting: an industrial system that could project abundance across thousands of miles of ocean while they struggled to maintain subsistence. The introduction of the B-29 Superfortress in June of 1944 represented a technological leap that Japan couldn't match even theoretically. The aircraft flew higher than Japanese fighters could effectively intercept, carried more bombs than an entire squadron of Japanese medium bombers, and possessed defensive armament that made it dangerous even when intercepted successfully. Japanese fighters attempting to engage B-29s at altitude found their engines starved for oxygen, their climb rates inadequate, and their armament insufficient. Even when fighters reached bombing altitude, the B-29's speed, more than 350 miles per hour at 30,000 feet, made sustained attacks difficult, and the Americans were building these aircraft in quantities that seemed impossible. By the end of 1944, over 200 B-29s were operational in the Marianas, conducting raids against Japanese industry with increasing frequency and devastating accuracy. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The home islands themselves became laboratories for understanding American production capacity. In November of 1944, B-29 raids against Tokyo's aircraft engine plants destroyed approximately 40% of manufacturing capacity in a single month. Japan's response revealed the depth of industrial weakness. The destroyed facilities couldn't be quickly rebuilt. Machine tools were irreplaceable. Skilled workers killed in the raids represented years of training. Production of the Nakajima Homare engine, which powered several frontline fighters, dropped from approximately 600 units monthly to fewer than 300. Meanwhile, American engine production exceeded 25,000 units monthly, A single raid had cost Japan more engine production capacity than America lost to all causes: combat, accidents, production defects in the same period. The aircraft themselves told the story of diverging industrial capability. By early 1945, Japan was still producing refined versions of aircraft designed in the late 1930s. The Zero, the Betty bomber, the Val dive bomber, these were excellent aircraft when introduced, but they hadn't fundamentally evolved. Incremental improvements in armament and engines couldn't overcome basic design limitations. American aircraft, by contrast, were different machines than those that began the war. The P-51 Mustang bore little resemblance to the P-40 Warhawk. The F-6F Hellcat represented a completely different design philosophy than the 4F Wildcat. American industry wasn't just producing more aircraft. It was innovating while producing, incorporating lessons from combat into new designs, and transitioning production from obsolete to advanced types without reducing total output. The specific case of the Mustang illustrated American industrial flexibility. The aircraft entered service in late 1943 as a long-range escort fighter. By mid-1944, American factories were producing more than 400 Mustangs monthly. The aircraft had better performance than the Zero at every altitude, longer range, heavier armament, far better protection for the pilot, and was easier to produce than Japanese fighters requiring extensive hand-fitting of components. A single Mustang could escort bombers deep into Japanese territory, engage Japanese fighters successfully, and return to base missions that Japan's entire remaining air force couldn't effectively counter. America was building them at a rate of nearly 5,000 per year, while simultaneously producing thousands of other fighter types. Japanese engineers examining captured American aircraft found another disturbing reality. The Americans were building better aircraft with less skilled labor. American aviation factories used standardized components, interchangeable parts, and assembly line methods that reduced the need for craftsman-level skills. Japanese aircraft production relied heavily on skilled workers, hand-fitting components, adjusting tolerances, and correcting manufacturing inconsistencies. This made each aircraft slightly different, complicated maintenance, and limited production to the pace of the most time-consuming operations. American aircraft rolled off assembly lines with tolerances tight enough that any component could be installed on any aircraft. This wasn't just efficiency. It was a different philosophy of manufacturing, one that allowed rapid scaling and consistent quality. The pilot experience gap had become a chasm by early 1945. American carrier pilots arriving in theater typically had between 400 and 600 flight hours, including extensive gunnery training, instrument flight training, and carrier qualification. Japanese pilots were entering combat with as few as 75 flight hours and minimal gunnery practice due to fuel and ammunition shortages. In practical terms, this meant Japanese pilots were learning to fight while fighting, and most didn't survive their first encounters long enough to become dangerous. The American system was producing competent pilots faster than Japan could kill them. The Japanese system was producing pilots so inadequately trained that many died in accidents before encountering enemy aircraft. The February 1945 raids against Tokyo revealed the final, brutal arithmetic. American carrier task forces appeared off the Japanese coast and launched more than 1,200 aircraft in coordinated strikes against aircraft factories, airfields, and ground installations. Japanese defenses managed to shoot down approximately 80 American aircraft, a loss rate of less than 7%, but the Americans returned the next day with 1,200 more aircraft, and the next day, and the next. After 4 days of continuous operations, American carriers had launched more than 4,000 combat sorties, lost approximately 200 aircraft, and inflicted damage that reduced Japanese aircraft production by an estimated 40%. Within 2 weeks, replacement aircraft and pilots had made good the American losses. Japanese losses: nearly 500 aircraft destroyed on the ground or in air combat, dozens of factories damaged, Hundreds of irreplaceable skilled workers killed were permanent. There was no reserve. There was no replacement system. There was only the grinding reality of arithmetic. Commander Gender, reviewing casualty, reports and production estimates in March of 1945, confronted numbers that made continued resistance seem less like strategy and more like suicide. Japan had perhaps 5,000 operational aircraft remaining, many of them obsolete or in poor mechanical condition. Fuel reserves were critically low. Pilot quality had declined to the point where many couldn't be trusted to conduct basic navigation. The Americans, intelligence estimated, had more than 40,000 operational aircraft in the Pacific theater alone, backed by production that exceeded 7,000 aircraft monthly. The ratio was 8-1. But this understated American advantage because their aircraft were newer, their pilots better trained, their logistics more robust, and their industrial base invulnerable to Japanese attack. The truth that emerged from these numbers wasn't merely tactical or strategic, it was philosophical. Japan had entered the war believing that spiritual strength, tactical excellence, and warrior discipline could overcome material disparities. This belief wasn't irrational at the war's beginning. Japan had defeated Russia in 1905 despite Russian advantages in population and resources. Japan had conquered vast territories in China despite economic weaknesses. The Bushido tradition taught that will and sacrifice could triumph over mere numbers. These weren't abstract concepts. They were the foundation of Japanese military culture, taught in schools, reinforced by propaganda, and validated by early victories. The aircraft production numbers destroyed this worldview more thoroughly than any battlefield defeat. What Japan faced wasn't simply superior resources, it was a different conception of warfare itself. America had industrialized conflict to a degree that made traditional military virtues almost irrelevant. Courage, skill, and sacrifice couldn't overcome an opponent who could lose 100 aircraft on Monday and replace them by Friday. Training and discipline became meaningless when the enemy could produce 10 pilots for every one Japan trained and equip them with aircraft so superior that even inferior pilots could prevail. The warrior tradition that defined Japanese military identity was being rendered obsolete by assembly lines in Michigan and California. Lieutenant Commander Sakai, one of the few pre-war naval aviators to survive the entire war, described the psychological impact in post-war interviews. He'd begun the war believing Japanese pilots were superior to any opponent. His early combat experiences confirmed this. He'd shot down American, British, Dutch, and Australian aircraft with relative ease. The enemies flew poorly coordinated attacks in inferior aircraft. They seemed inadequately trained. Japanese tactical excellence appeared decisive. But by 1945, Sakai found himself fighting Americans who were as well trained as pre-war Japanese pilots, flying aircraft that were superior in every measurable category, supported by logistics that seemed unlimited. The realization wasn't gradual, it was crushing. Everything he'd been taught about Japanese superiority was propaganda. The truth was arithmetic. The human cost of this realization extended beyond the pilots who died in unequal combat. It touched the factory workers who labored 20-hour days producing aircraft they knew were inferior. It affected the engineers who understood that Japan lacked the aluminum, the high-octane fuel, the precision machine tools, and the electrical systems that made American aircraft superior. It devastated the military planners who'd committed their nation to a war based on assumptions that proved catastrophically wrong. These weren't stupid men. They were intelligent, dedicated professionals who'd made calculations based on the information available in 1941. But that information was wrong, and the consequences were measured in hundreds of thousands of lives. The specific case of aircraft production illustrated a broader failure of understanding. Japan's leaders had assumed industrial capacity was relatively static, that nations possessed a certain level of manufacturing capability that could be expanded modestly but not transformed. This assumption was based on Japan's own experience. Japanese industry in 1941 was operating near maximum capacity. Expanding production required building new factories, training new workers, and securing additional raw materials processes that took years and competed with other economic needs. The idea that America could triple, quadruple, then quintuple aircraft production in 3 years seemed to violate basic economic principles. But it didn't violate American economic principles. It only violated Japanese assumptions about what industrial economy could achieve. American production scaled exponentially rather than linearly. The Willow Run plant in Michigan, operated by Ford Motor Company, produced B-24 Liberator bombers at a rate that seemed fictional to Japanese observers. At peak production in 1944, the plant completed 1 bomber every 63 minutes. This was one plant, producing 1 aircraft type, and it outproduced Japan's entire bomber manufacturing industry. The plant employed 42,000 workers organized into precision manufacturing operations that broke aircraft construction into repetitive, trainable tasks. Workers didn't need to understand the entire aircraft. They needed to master one operation, perform it consistently, and maintain quality standards. This was industrial mass production applied to weapons manufacturing, and it achieved results that craftsman-based production couldn't match. The Japanese aircraft industry, by contrast, relied on skilled workers, performing complex operations that required years of training. A Japanese factory worker might spend a decade learning to hand-fit aircraft components, adjust tolerances, and correct manufacturing variations. This produced excellent individual aircraft, but limited production volume. When American bombing destroyed Japanese factories, the skilled workers died, and their knowledge died with them. Replacing a factory took months. Replacing a master craftsman took a decade. America's system was resilient because it didn't depend on irreplaceable expertise. Any factory worker who could follow instructions could be trained for aircraft assembly in weeks. The system, not the individual, held the knowledge. The pilot training disparity reflected similar philosophical differences. Japan viewed pilots as warriors who required years of formation to achieve the spiritual and technical excellence demanded by aerial combat. This produced superb pilots, but in small numbers and at unsustainable cost. When these pilots died, their experience died with them. America viewed pilots as technicians who required thorough but time-limited training in specific skills: navigation, gunnery, formation flying, emergency procedures. The training was systematic, standardized, and scalable. It produced pilots who were competent rather than excellent, but it produced them in quantities that made individual excellence less important. A squadron of 20 adequately trained American pilots in good aircraft would defeat 10 excellent Japanese pilots in inferior planes. The mathematics of combat had changed, and Japan's training philosophy couldn't adapt quickly enough to matter. By April of 1945, these realities had become undeniable even to the most optimistic Japanese planners. The final production estimates showed America had manufactured approximately 300,000 military aircraft during the war years. Japan had produced approximately 76,000. The ratio, nearly 4-to-1, understated the true disparity, because American aircraft were larger, more capable, and technologically superior on average. More critically, American production had been sustained while simultaneously building the world's largest navy, supplying allies with thousands of aircraft and vehicles, and maintaining a civilian economy that provided living standards Japan couldn't approach even before the war. This wasn't just industrial superiority. It was evidence of an economic system organized on principles Japan didn't fully understand. The specific month of April 1945 illustrated the final arithmetic. American factories produced approximately 7,000 military aircraft that month. Japan produced fewer than 800, and many of these were training aircraft or obsolete types kept in production because no alternatives existed. More than half of Japanese aircraft production was immediately consumed by kamikaze operations, one-way missions where aircraft and pilots were expended to achieve marginal tactical effects. This wasn't a sustainable strategy. It was admission that conventional aerial combat was no longer possible. Japanese aircraft and pilots couldn't defeat American forces in normal operations, so they were being used as guided missiles. The warrior tradition had been reduced to organized suicide because the arithmetic of production had made fighting suicidal. Commander Genda, reflecting on the war in later years, identified the moment he understood Japan had lost. It wasn't at Midway, though that battle was catastrophic. It wasn't in the Marianas, though that defeat was devastating. It was in late 1944, when he saw production estimates showing America was building more aircraft in a single month than Japan had lost in the entire Guadalcanal campaign. The war wasn't about strategy anymore. It wasn't about tactics or training or warrior spirit. It was about arithmetic, and the arithmetic was overwhelming. Japan could fight perfectly, could achieve victory in every tactical engagement, and still lose because America could replace losses faster than Japan could inflict them. The psychological cost of this realization was profound for men who'd built their entire identity around military excellence. They'd trained for years, studied their profession deeply, and believed their dedication and skill mattered decisively. Discovering that they were irrelevant, that the war would be won or lost based on factory production in places they'd never seen by people they'd never met, was devastating in ways that battlefield defeat wasn't. A soldier can accept losing a battle while believing the next battle might be won. Accepting that the outcome was predetermined by industrial capacity eliminated even the possibility of redemption through courage or sacrifice. The final months of the war saw Japanese military leadership grappling with a truth they'd known intellectually since late 1944, but couldn't accept emotionally. Continued resistance was murder, not strategy. Every pilot sent into combat against American forces in mid-1945 was effectively being killed to maintain the fiction that resistance remained meaningful. The kamikaze strategy, presented as the ultimate expression of Bushido spirit, was actually admission that Japanese aircraft and pilots couldn't survive conventional combat. Sending men on suicide missions wasn't Bushido, it was recognition that the arithmetic had made survival impossible. The August 1945 surrender ended fighting but didn't resolve the psychological crisis for men like Commander Genda and Lieutenant Commander Sakai. They devoted their lives to naval aviation, believed in Japanese superiority, and witnessed their worldview systematically dismantled by arithmetic they couldn't contest. In the occupation period, they saw American abundance firsthand: well-fed troops, endless supplies, casual waste of materials that Japan would have treasured. This wasn't just defeat. It was confronting evidence that the entire war had been based on catastrophic misunderstanding of what modern industrial warfare required. The lesson wasn't that Japanese pilots were inferior or that Japanese engineers were incompetent. Individual Japanese aircraft like the Zero were excellent. Japanese pilots were highly skilled. Japanese tactics were often sophisticated. The lesson was that individual excellence couldn't overcome systematic industrial superiority. War between modern industrial powers was decided by production capacity, resource access, and the ability to translate economic strength into military force. Japan had entered this war believing it could compensate for economic weakness with tactical excellence and warrior spirit. The arithmetic proved otherwise. 300,000 aircraft against 76,000, 4-1. The numbers were simple. The implications were devastating. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.